What's going on, you guys? So we're going to work on intersection of two arrays 2. So the idea is we get two sets of arrays, nums1 and nums2, and we need to return the values that appear in both of them. So in this case, 2 appears twice in both arrays, so we return 2, 2. In this case, in the second case, although 9, 4 appears twice in the second array, it only appears once in the first, so we only return 1, 4, and 1, 9. Okay, so each element in the result should appear as many times as it shows in both arrays. The result can be in any order. Okay, let's think about this. So we could create nums1 count, and that would be a hash map of num and count in nums1, and then we could loop over nums2, and if we find a value in nums2 that is in nums1 count, we can add that value to our result with a few like we need to make sure we only add it, like for example in this one, add 4 once and 9 once, not twice. So also considering how many times we're going to add them. So let's see. Let's do some pseudocode here. So we'll create nums1.count. Let's say get count nums1, and then we'll have a result. It'll be a list, and let's see. So for num in nums2, if nums1 count of num is greater than 0, we'll add that to our result.add num. And we'll do, so here's where we're going to keep track of the number of times we're adding it. So then we're going to decrement that result. So we'll do sorry, detail there. Okay. All right, there we go, and we'll decrement this value. So if it's 1, it'll go down to 0. If it's 2, it'll go down to 1. So that way it's going to keep track of how many times should we add the same number. And then at the end, it wants an int array, so we'll just return result to int array. Then we also have to do the get count function. So that would look something like, let's see, get count array. And say make a map equals map of ints, and for num in nums we would do map.put num, what would we put here? Num map.get or else num or 0. So let me explain the second part here. So when num is not in map, this will default to 0, and then we'll add 1 to 0, so it'll be 1. So we'll get num1. When num is already in the array, we'll just add 1 to the previous value. So that's pretty cool. And then we'll just return map. Okay. All right, so let's convert that to Kotlin. Let's see. We might need men. I don't think we'll need men. Let's see. Okay, 17. Let's see here. Okay. Create var here. This is going to be a mutable list. And this is going to be in parentheses. What else? Okay, so let's see, what else? Converting to Kotlin, let's see. This needs to be a function, and this needs to be, oh. I think that's right, let's see here. Oh, one too far. Okay. Fun, get count, this will be an int array. We'll return a mutable map of ints. Okay, what else? It's going to be var mutable map of ints in parentheses. Just cleaning this up a bit. All right, let's see if that works. Oh, wait. Just saw that. Okay, let's see if that works. Nope. Okay. What's the problem there? Oh, so we don't want to call that function there. Okay. So this could be null, so this is why this is complaining. So can we do does not equal null. Okay. We forgot these. Okay. So we're just doing a null check before. Let's see. Okay, so we're still having an issue here. Oh, okay. This is array. Okay. And, okay, so we're having this null check issue. This is annoying right now, but it's a lot better than having to deal with a null pointer exception when our program is already running. And that's the point of going through the pain of like handling null as we're writing our function, is we don't have to handle a null pointer exception when our code is running already. And maybe some clients or users are using it. So sucks right now as you're writing it, but it pays off when we don't have to deal with null pointer issues. Okay. So we can just do, we can do that get or else guy. We can say get or else num or 0. So if it's 0, it will fail this check. And so we can just get rid of this. So that should work. Okay, there you go, guys. So let's think about time and space complexity. So time complexity, we run through both. There's 2 for loops, not nested. We run through both elements. So O of n plus m, where n is the length of nums1, m is the length of nums2. What else? Let's see, space. So we use we create a map and a list. In worst case, so we're only creating one map. But worst case, we have all unique values, and so we need to create a map that's the same size as n or m. So this is like O of n. Okay. And so they asked this question. So what if nums1's size is small compared to nums2's size? Which algorithm is better? So if we create a hash map, so here we're creating a hash map with nums1. If nums2 is smaller, so for example here nums2 is smaller, we could use less memory by using nums2. So, and we could improve O of n. We could do the min of n and m. So that's a little bit better, right? So how do we do that? So we're doing, we're creating a hash map with nums1 by default here. So if nums2 dot size is less than nums1 dot size, we'll just recall the function and switch the order. We'll call nums2 and nums1. And that way we'll create a hash map we'll create a hash map with, for example, this guy instead of this guy. So it'll save us a little bit of space. And so we go from O of n, O of the first one to O of the min. So it's a little bit better. Let's see here. So again, we just flip the order of the input arrays. Interesting, but it took longer. So LeetCode servers, sometimes there's just variance on different calls. Yeah, so the first time it's slow and the second time it's fast, so. But this is a little bit better in this case when nums2 is going to be shorter than nums1. All right, you guys. That has been intersection of 2 arrays. 2 arrays 2.